So I have a ESP32, ESP8266 Wemos D1 Mini that I have MicroPython running on. I set this up earlier in a previous video, so if you're interested, check that out. Basically, I use MicroPycraft to flash the MicroPython firmware to it. So basically, I have that running now. And then I got on eBay a 16x2 LCD with an I2C interface. So basically, came separately. Soldered that on and got it all connected. So right now, so I just have the MicroPython running on here. I haven't written any code yet, but I have this going, and right now I'm not seeing anything. I think they're just for contrast. Oh, there we go. Okay. I'll have to mess with this a little more later, but I think that might be, okay, so maybe that's what it's displaying. All right, so basically want to get this connected. We'll see if we can find some libraries to write code for this. So right now, I think that's the contrast is set all the way. See if you're actually able to see that. It looks okay here. It just looks like solid blocks on the top row here. But I can see in the camera we're not getting a really good image on that. So we'll have to see about that. Okay, so at this point, so I've got MicroPycraft here connected to my COM3. It's an ESP8266. So the first thing I want to do is I want to find some libraries for connecting this. And so I'm going to look, so let's do like MicroPython 16x2 LCD. So it looks like somebody else is also looking for that. So looks like we got a few different options here. Made some research. Yep, Wemos D1 Mini. That is what or rather, yeah, so it doesn't matter. That's what I have though. So it looks like there's some drivers. This one references this chip, I think. So the one that I got, let's see if I can find this here. So it was not that one. Let me find this here. It's not going to show me what I ordered recently, is it? And, oh, right. So these, I actually got these off Amazon, which I was quite impressed by the price. I think I paid $10, $12 for 3 of these screens, which is amazing stuff that we get. Okay. All right. So the ones that I got were these here. So this, it says, is this chip, which I think if I look at the back of this, I want to say, yeah, this is just the T chip, so not the AT. Which that's nice to know because the address is going to be that, which might come in useful. But so I am going to search for MicroPython LED display, that one. All right, so it doesn't show exactly that one, but I do see, if I search, yep, so address lines. All right, so looks like we have some reference here, and it looks like, yep, there. This is very, very similar to what I have here. So we've got basically just on the other side, yeah, so I got the plus and the minus, and then actually I think I set up the same pins. So probably, yep. Okay. So I'm gonna see if I can find, so I squared C, so let's see what we got in here. Yep, so it looks like he has a class. There's a class there. Yeah. That's a HD 44 780 character LCD connected via PCF. Alright. I think this is probably a good, get this, take this and in here, and then I'm actually going to, let's see here. I don't know what the actual location of this workspace is, but let's see here. I'm not even really sure where to set where the workspace is, but alright. So I'm just going to save this as I2C LCD. .py. Not sure where that went. Oh, it went in here. Okay. Try closing this and reopening. Alright. Okay. So we're back and connected. There's. Okay. Yep. Yeah. So this should work pretty well. Okay. So we'll see what this other. So we have that code, and then got an LCD test. Okay. So this might do it for us. Yep. So default I2C address. That should be the default. We'll see what this is. actually just save this as the boot.py, which I'm not gonna do, but I will just call this test main. I'm actually gonna comment this out so we won't immediately run it, but I can import it. Test main.py. Copy this up to the device. So it's kind of nice because you can just copy these up here. And then it's on that. So then in my boot.py, I say import, actually I want to say from and test main import test main. Save it. And then I'm going to say test main. Alright, let's see if this works. And I think let's see here, print testing 1, print testing 2, save it. Okay, nothing out, and reset this. And nothing. Okay, let's see here. Let's say import test main. Okay. So it looks like, okay. I2C, okay, so I'm going to rename this actually. Rename that on my file system, and then I think, let's see, I'll close this out, open it again. There's no option to reset at the moment, apparently, in MicroPycraft. MicroPycraft definitely seems to have a lot of like possibilities, but it's somewhat lacking in implementation details. Okay, so I'm going to delete this one. Alright, let's see here. And that did not save at all. Okay, so I'm going to make a new folder here. We'll call this 16 by 2. And test main. Yep. Alright. Okay, not. Since I don't know how to refresh it, I created a new folder in there. I'm just going to have to close it again and open it. Alright, so connect to this. I think it defaults to ESP32, which, oh, no, it flips back to that. Okay. I made a 16 by 2 folder here. I'm going to download the boot Pi into that folder. File cannot be made. Okay. Alright. Oh, maybe I just need to create a new one. Alright, let's say from test main import test main print hello world 0. And we'll do that, and then do test main. Alright, let's save this as boot.py 16x2 boot.py. So that was supposed to put that in there, which it looks like it did in the actual file. Okay. Yeah, I could definitely use some sort of refresh functionality in here that'd be useful. Alright, yep, there we go. So it did say that. Okay, serial 3, connect there. Alright, so I got that uploaded. Not sure if it's doing anything. Okay, there we go. No module named LCD API. Okay, now we're getting somewhere. Okay, so to debug this, so this is in the file ESP8266I2C underscore LCD pi line 4. There is no module LCD API. Okay, so to find that, it looks like, okay, so there's basically more files here. Yep, so it looks like we need to download this. Let's see, is that, just double check. Yeah, LCD API, and then that has LCD class in it. Perfect. Okay, so I'm going, and then that one imports time, so it doesn't need anything else. Okay, so we'll get the raw one of that. Control A, Control C, copy all. Okay, Control N, and then this is going to be called LCD underscore API dot pi. LCD underscore API dot pi, and this needs to go to 16x2. And yep, okay. So that generated, again, I don't know why. Open, I can open the folder, but I cannot refresh. Control R? No. Alright, I guess that's my complaint. No, there we go. If I copy something, then it refreshes. Alright, so copy LCD API over here. Let's refresh this. Okay, not sure why that froze, but close it and open again. Can't import name, LCD API. Alright, what do we got now? Well, there's nothing in there. Yeah, we'll have to copy that again. There we go. error name OS is not defined. So I'm not sure exactly how the contrast is supposed to be adjusted on this. I'm guessing that is showing it more, but we'll see. Okay, so OS error ENO dev. Okay, so that is on line 26. I2C address.
Oh my gosh.
I'm just doing a live stream on YouTube. Right there. It's looking at this is the live stream here. Do you want me to send you the link so you can watch? No.
So you're a hacker?
Yes.
I'm just like, I was wondering if we have some more. Yeah.
Sure. Okay, so I2C address, it apparently doesn't like, dev, so apparently whenever it initializes this, so I2C LCD, which is initialized, I think over here, default I2C address, that should be totally fine. Test main pi, line 15. Alright. Alright, so let's try some stuff here. So back down the REPL. See if I guess first just make sure my lines are configured as I think. So I've got D1 and D2. Let's see, D1, which is the yellow wire, is connected to SDA. Let's make sure that's accurate. So D1 Mini MicroPython. So I found basically the pinouts somewhere here. No, that wasn't it. So the D1 Mini. Find the pinouts. There we go. All right. So D1. So right now I have the D1 connected to SDA. Oh, maybe I'll flip this. SDA. Looks like the normal method flips it the other way. So pin 4. Yeah, it's okay. So I just need to flip these around the other way. And then pin 5, which is... So the confusing things about these is that pin numbers don't match up to the pin numbers on the board. So we have like our D1 here showing so pin 5 is SCL, and that's just, I think, just by somebody just decided that. I mean, those could be flipped, but then I got to flip it, and I would rather just use what kind of the standard here is. So it looks like SCL is D1. SCL, which is the orange pin. Okay, so I'm just going to turn this off and flip these pins around. Who knows, maybe it just works after this. Alright, plug this back in and see what happens. No, nothing shows up, so. No, it works. We have numbers. Alright, there we go. Yep. I don't know if you can see that, but there's stuff showing up on the screen. So it was literally just those pins were flipped around. So, not sure if you can see that, but just counting up 50, 52. Alright, so once you wire it up correctly, which, so basically it's wired to the SDA and SCL. SCL is in this one, so pin 5, which would be D1, and then SDA is pin 4 in Python, but pin D1 on this board. So yeah, I've got this working. It's counting up 86, 87, 88, 89, 90, turns off 91, 92, 93, 94. All right, cool. So that works. So I got a little library here, the LCD API. So I will post this link in the chat, so anybody, or in the link here, so that if anybody is interested, you can pull these together. But yeah, basically it looks like this project here that this person did, D Highlands, yeah, can be used. It's got all the files and drivers that are needed. So check it out and have fun tinkering with MicroPython on an ESP8266. Thanks for watching, everyone.